Chapter 3, Video 6, LT6. It's Miss Audrey.
And Miss LaHart, which was
Hey, Miss LaHart, why do lumberjacks make good musicians?
Dun, dun. I don't know why.
Because of their natural logarithm.
Oh my God.
Ah, okay, so let's go, people. Logs are fun.
Logs to some of you were scary last year, but like just suck it up and get used to it this
Yep.
year. It's how to rewrite an expression so that your exponent pops out front.
So in a situation like this, when we have a variable exponent, it's a little like, oh my goodness, it's kind of intimidating.
Yep.
But with the way we've been doing it, we can simply say 25 to what power is 5x, or 5 to what power is 25, right? So we could have changed this to 5 squared and done x equals 2.
Yep.
However, with logs, we can rewrite it with log base 5 of 25 is x.
A log is equal to an exponent. I'll say that again. A log is equal to an exponent. So back in the day, before calculators became so calculator savvy, you'd have to use log charts.
Right there.
Okay, to find at what it equals. But now our calculators have such a big processor that they know every single exponent.
Sure does.
Like we had before, it popped up 5 to the x equals 3. Do you know the exponent on
Sure
a 5
don't.
to get a 3?
Nope.
But your calculator
Let me
will.
show you that part again. No, I don't.
So that's why we need a better form of finding what logs are. Your calculator is going to come very handy this year.
Oh, yes. Now, in test mode, you can't type it in like that, but we'll get to that later.
Yep.
So, logarithms are inverses of exponentials.
Logarithms undo exponent. A log is an exponent.
Log is an exponent. Log is an exponent. Come on, people. So, let's rewrite them in logarithmic form.
Okay, your base becomes your little number. So the 16, and it makes a kind of a swirl situation going on. The base is always that little number, so you're going to have log of base 16 of 256 equal to. Your exponent is always what a log is equal to.
Yes, the easiest way, the way that I always think of it is the base is always the same as the base on the exponent. The purpose of a log is to solve the exponent, and then the other number just fills in the blank, if that's helpful.
Okay. So here it is again. Again with negatives, you can have, you know, log equal to a negative.
Log base 2 of 164 is -6. The circle only works if the term with the exponent is on the left.
And then you have to be able to go in the other direction to write this in exponent equal to. So 13 squared equals 169.
Boom. Okay, we're going through these a little quick because you have seen these before. Okay, a common log simply means the base that's implied. So just like 1x, x, the coefficient implied is 1. With a log, the base implied is always 10.
Yep. Okay, natural log. Now, there is a number that we've talked about. Yes, Jacob Bernelli actually founded or discovered E, whereas Leonard Euler actually took credit for it. He's a sexy-looking guy. Okay, E is a natural. Yes, it's like pi, but you know
it's number.
Yep. And then if you see it, where do you see it in actually real life statistics? Okay, normal distribution, all that jazz. Biology, you can see it in populations. Physics, it just comes up in nature. It's one of those numbers that happens all the time.
Compounding.
All that jazz. So a natural log, we use ln. Again, don't really ask us where the ln came from. Natural log, you would think they'd do nl, but whatever. Go with it. The base is E.
The base is E.
The base is E.
You only use a natural log if E is involved. You shouldn't have natural log written down unless E is involved with the situation.
Yep.
So rewriting it in exponential form, again, the base implied is E. So this is E to the 4th equals -2x. E to the, I forgot. There's
You always got to isolate your ln.
Yep. Divide by 9 first and then go.
Yep. So now it would be E to the 4/3 equal x.
Boom.
Okay.
And then going backwards, so again, we're gonna move it so that the variable or the exponent term is on the left, and then your little circle will work.
Yep. You don't have to rewrite it, but you just have to know what component goes where.
Right.
Okay. Remember, ln. Can you write it with the base of E? You can. You don't have to.
It's not wrong, but it's implied.
Yep. All right. So now we are gonna show you how. Well, we're gonna do this in our head first, people.
So remember, a log is an exponent. So what this is actually saying is 5 to what power is 25? Well,
2.
That's 2.
Okay? The exponent on a, that's what you should say in your head. The exponent on a 5 to get a 25 is 2.
The exponent on a 2 to get 1/8 is -3.
And now we can use our common, remember last learning target where we use common bases.
And then when you drop the base.
And then you drop that base. Okay? What's the exponent on a 3 to get a 243? 5.
And some of these might take some guessing checking if you're trying to just do it this way.
If you see 1 over something, you know it's going to be a negative that's going to pop out. So 5 to the what power is 125? 3, so that's a negative 3.
Down here, 6 to what power is 1? Remember, anything to the 0 power is 1.
So that would be equivalent to 0. And then that one is going to be negative 5.
Woo! Now, sometimes my brain just doesn't think so quickly. So there are ways to get these answers without just guessing and checking and all of that, and we will get into that later.
Okay, logs, if you see a common log, it's really kind of simple. Just count your zeros. That's a trick. 10 to what power is 10,000? 4. So that log of 10,000 is equivalent to 4.
Okay, now this one's a little tricky. 4 to what power is 2? So we're kind of going down. What's the only way I can go down with an exponent? If I have a
Fractional exponent. So 4 is the same thing as 2 squared. So this is common basis, what you did last learning target. So x equals 1/2.
Now, conversely, if you also remembered that the square root of 4 is 2, and you remember that a square root is an exponent of a 1/2, you could have gotten there that way too.
Whatever works.
Lots of different
All
ways.
right, natural logs, you have to be able to evaluate and remember. It's just e to what power is e?
I find natural logs super easy because
Yes.
it just basically undoes it.
Yep. Okay, ln of e is just 1. Again, that's a big one we'll come back to. This one, basically it's just going to be whatever the exponent is on your e power. Okay? As you can see, we're setting up the e to the what power is the expression and then solving it from there.
Okay, just a reminder, 2 to the what power is 4 to the, or the 5th root of 4. Remember, power over root.
Oh, my
And it's
animations will
gonna
come
be-
up.
ooh,
Here they are.
Power over root. And then don't forget that 4 is 2 squared. We did the common base root on that one. Okay. We will show you how to use the calculator. Some of you might remember, but that's it for now.
Try it in your head first.
Have a great
Don't be
day.
chicken.
Remember what a log is.